I'm Ismanov. Here we are in the corn plots. We are doing here the irrigation experiment with different treatments of the corn. All the poly pipe is installed in the beginning of the plot with the blue gates. The blue gate is very useful tool that allows to open and lock the water in each row. We can change the timing and irrigation date with this tool. We have here two irrigation treatments. One of the irrigation on the base of the calendars, means every week our farmers doing this, we irrigate, and then we irrigate also the base of the watermark sensors. And we have the app, we can find out when we have to irrigate the corn in different stages. Here the stages are almost close to the end of the maturity. Just have a little green leaves here. Probably after the 3-4 days we're able to harvest this corn. During the experiment we measure a lot of corn plant data, including height, the leaf area, and diameter, and weight, and the moisture content, all of the different elements of the corn that give us evaluate the hard changes of the parameters during the whole season, from the beginning to the end, and then find out how we can irrigate or use the fertilizer as the treatments in the corn. Apart from here, some sensors, canopy temperature or leaf temperature sensors installed on next soybean plots, and the same sensors we use here on corn. And during the whole season we measure the leaf temperature of the corn. They also give us to compare this data to the weather data and find what the temperature of the corn during the whole season. This equipment could measure every 10 minutes of the temperature. That is very good data to compare with the same intervals of the weather data taken by the weather stations. Here we have some soil moisture loggers connected to the watermark sensors. These watermark sensors installed at 6, 12, 18 and 30 inches depth of the plot that could give us the whole picture of the changes soil moisture from the beginning to the end. Also uses the holes we taken from this soil to measure the granulometric soil moisture that give us compare the watermark moisture data with the granulometric and find the equations and calculate how in reality soil has the moisture and water content, and create the soil water balance equation for the whole season. This complex measurement of the corn during the whole season could give us a real picture of how the corn plant is developing, depend on weather, soil moisture and other parameters, and find the optimum conditions how we can increase the yield of the corn. As you see, above the corn canopy or above the corn plants, we have the weather station. This weather station measures the whole weather data above the corn. In the middle height of the plant, we install another weather station, Spectrum, the technologies company. It's called Watchdog 2000, and we developed this equipment with a special extension that put the air temperature and the air humidity sensors right on the between leaves of the corn, that give us the chance to measure air humidity and air temperature right in the plants, also above the plants, and compare them during the season in different situations, irrigation, rainfall situations, and dry situations, and make some decisions on the basis of this data. And also we install here you see the cables goes to the plants installed inside of the plots, the subflow sensors. These subflow sensors, through the cables, they're connected to the logger flow 321K. So this logger could measure the 8 plants subflow in the same time with the same interval that we are measuring the soil moisture and soil temperature, etc. All these measurements they're doing in the same time. We can log it and download the data at any time. This logger consists from the logger, the inside. You can see the SR 1000 produced by Campbell Scientific. So this is very good the logger. And we have the part that distributes voltages to the loggers. Here's another part of the field planted with soybeans. Soybeans planted earlier in these plots. They are already mature. Also we have the soil moisture sensors of the soybean plots and subflow sensors here. And we have also planted another part of the field with the late soybeans that also connected through the subflow and the other sensors to the logging. This project could measure all the complex things from the beginning to the end of the season. They depend on planting timings and depend on soil moisture and irrigation treatments, how it changes the yield data. So in the end of the season, we measure the yield and find out what the condition the best for the soybean and corn plants to achieve the maximum yield. Thank you for watching.